So good morning, everyone. So my name's Kevin. I'm a member of the Enyo JavaScript application framework. And Enyo is a framework for creating native quality applications on the web stack. And today I'm going to try and make the argument, try and convince you guys that the web really does need a better object-oriented programming model for creating applications, specifically if you're trying to create native applications. So Enyo is pretty new. We just open sourced it this year. So we've been doing a lot of meetings, getting out to a lot of conferences like this, trying to get the word out about Enyo. And my colleague mentioned to me the other day, he said, do you think Twitter has to go out and try and convince people to use Bootstrap as much as we have to get out there and try and let people know about Enyo? And I really had to, it made me think, why is it so hard to get the word out about Enyo? What are we doing wrong, right? But then it occurred to me. So Bootstrap is this awesome library for creating beautiful web pages on the web, right? And in 2012, developers don't have to be convinced that it's possible to create beautiful websites, right? That's a given. But Enyo, on the other hand, is a framework for creating native quality applications. And frankly, in 2012, it's still a stretch for a lot of developers to believe that the web has the power to create applications that can compete with the quality of applications that you'll find on iOS and Android. And quite frankly, not all of our friends in Silicon Valley have been doing us any favors, right? So thanks, Mark. But here's the thing. At WebOS, we know that it's possible because we've already done it. So last year, the HP Touchpad launched with a slew of core applications that were built with nothing more than HTML, JavaScript, and CSS, because on WebOS, that was the application stack. And so Enyo was really born out of this need to be able to give developers a framework where they could consistently create high-quality applications using JavaScript and HTML that were high-performing, touch-friendly, interactive, things that people expect out of native applications without having to reinvent the wheel every time. And here's the thing. WebOS applications, although they were built with web technology, HTML and JavaScript, they weren't being compared to websites. They were being compared to iOS applications, Android applications. And that took some rethinking. We really had to change the way that we thought about developing applications on the web. So that's kind of a big statement I just made. And a lot of people are probably thinking, there's a million cross-platform frameworks for creating applications, right? Why do we need to rethink? Why do we need yet another one, a different way of doing it? So I want to kind of go through some of the techniques that are available today that a lot of frameworks use. And specifically, keeping an eye on the goal of creating native quality applications. I want to kind of walk through what we have. So first, there's a lot of great frameworks out there doing awesome things around data modeling, data binding, keeping views in sync with their underlying data. And that's awesome. We love that. That's something that the web totally needs. But the problem with a lot of these frameworks is that they really kind of punt the view layer to HTML templating. And when you're creating websites that are primarily content-driven, templating is a great solution. So if you've got a view that needs to look like this, templating can get you there really easily, right? But when you're thinking about creating native quality applications, those are typically going to build with users expect to find higher level, more interactive, richer controls that these applications are going to be built out of. So if you take the example of a slider like this, so you'll find this in any shopping app or travel app. It's a rich, interactive control. And asking a developer to try and get to here using HTML templating is a stretch, right? You really have to, you need to start with HTML. You need to understand the CSS. You need to put it all there. And once you've done it once, you don't want to do that, over and over in your HTML templates, right? So, sure, probably a lot of people in the crowd are thinking, well, of course you wouldn't want to just build that from hand every time. You would go grab a jQuery plugin, something like that, to do your slider for you. So that's true, and jQuery is an awesome library, right? Like half of the websites on the internet use jQuery, and it's for a reason. It's because jQuery is a great and Bootstrap and a lot of other UI libraries, they're great at adding interactive controls to web pages. So here's a web page, a pretty typical kind of Bootstrap-based web page, where they've used some of Bootstrap's jQuery-based interactive controls on it. And that's a great solution for that. But again, if you're thinking about typical native applications, So picture the Facebook application that's running on your phone right now. And picture how you would try and do that just using jQuery. And thinking about all of the views that need to be created. All of those views might have lots of interactive components that need to get hooked up, created into the DOM, hooked up to JavaScript, and then torn down as the user navigates through a lot of different views. And sure, you can try and do this using jQuery and other UI libraries, but managing that lifecycle, because native applications are long-lived, you don't get to reload the view every time the user goes to a new screen. That needs to be dynamically created, hooked up, and then torn down as the view changes. And so asking a developer to do that kind of with the current tools is really asking a lot. The developer has to manage that lifecycle kind of on their own. And our kind of thinking here is that if you give 100 developers these tools and ask them to come back with applications that can really be confused with or compete with iOS or Android applications, most people are going to have a hard time. And so here's where I kind of make the pitch for the solution that we use in Enyo, but it's a solution that we think is generally applicable to most web development. And that's the idea of components. So when we talk about components, the main thing the main focus here is this notion of encapsulation. So the idea is that we're going to put inside of a JavaScript object for any one chunk of application functionality, we're going to capture the markup that's required to create that view. Any of the event handling that's required to make that piece of functionality interactive and respond to user events. We're going to take any logic that's required to make that component do its function, put that inside the object, and then we're going to give it an API so that the component knows how to create itself, initialize itself, render itself into the DOM, and then tear itself back down when the view needs to get destroyed. And what we're going to do is we're going to take all of that, draw a box around it, and then put that inside of a JavaScript object. And now, instead of building our applications using these amorphous chunks of HTML and JavaScript, instead we're going to start building our applications using objects, using components that have a well-defined interface. And if this and the components hide their functionality hide their implementation from the user, so that you're working with these well-defined interfaces. And if this sounds familiar, it's because it's what we all learned in computer science class, right? This idea of taking a big problem, like a complex application, breaking it down into smaller building blocks that are manageable, giving those building blocks a well-defined interface, and then hiding the implementation so that the developer only has to worry about using that object. And so to make this a little more concrete, let's take the example of a slider. So this is just kind of a simple slider. And let's think about what it would take to encapsulate all of this slider into a JavaScript object that we could then use to build applications, right? So, okay, so let's think about the DOM that we'll need to create. So say this slider is created out of 4 divs that create the structure of the slider and some CSS applied to it. So we need to be able to capture that in JavaScript. So it turns out that JavaScript object literals are actually a pretty nice way to capture hierarchical data. And so this is the technique we use in Enyo to get a representation of the DOM that we'll need into JavaScript. So we take these divs here, and we convert that into a JavaScript representation of those. So now that view can be encapsulated into the component. So now let's think of the lifecycle management that we might need to do for this slider. So the slider is pretty simple, but when we initialize it, we might want to give it an initial value of the position that's passed in on the constructor. So that would be something that would need to be handled specifically for this component in its create and render lifecycle functions. Okay, so the slider needs to be interactive. So we need to be able to capture events coming up from the DOM, so things like drags and taps. That might need to change the internal state, apply some new CSS styles to move the position of the little knob, right? So those are things that we would also encapsulate in the object. And then any state or logic that the slider will need. So for example, we might want to give the slider an API so that not only users can drag it, but we can also programmatically change the position. So that would be an API and some logic that we would put on that component. And then once we've done that, we wrap that in a JavaScript object that extends from our base component class And we've now created a new class that can be instantiated and rendered. And we're working all in JavaScript now. So we no longer need to think about the DOM that needs to be created by this component. We can just create it and then ask it to be rendered. And we can do that as many times as we need because it's a class that can be instantiated. And that's something we think is pretty cool. So using that same technique, we can now create components for all sorts of widgetry UI components that are needed to build applications. So hopefully that sounds pretty good, right? But if we stopped there, components would really be useful for little more than creating widget libraries, UI libraries. And at least in Enyo, we see components, kind of this component model, as being a much more powerful construct. And we do that in a really simple way. Instead of just being able to express the view that we're capturing in the component in terms of HTML, we can also capture it in terms of compositions of other components. All right, so that's key. So I'm going to walk through an example here where we're going to take some kind of low-level, simple components and compose those into higher-level components. So, okay, so let's start with this, something really simple, a label. So this might be a component that all it does is create a div, render a string out into the label, really simple. So we can inherit from that label and create an integer label, which does the same thing, only it takes a property on its API and it parses it into an integer and sticks that into the label. So that's not real exciting, but we can compose these two things into a brand new component called a value label. So this is now a new JavaScript component that encapsulates, that composes those two previous components into a brand new component that can be rendered out. Still not real sexy, but hang on, we'll keep going. So we can take this value label and then combine it with a slider that we just made, right? So now we can combine those two into a new thing called a labeled slider. Okay, so now it gets a little more interesting because in the implementation of the labeled slider, we can handle events coming up from the slider to automatically change the value of the value label. Okay, so we've now composed two components and then added more functionality to create a brand new component called this labeled slider. Okay, so we'll keep going. So we can take this, so let's say our application had an array of attributes, and each attribute has a name and a value, and we want to create a simple editor for those. So we could create a new component that we can give this array. We can hand this array to the component, and the component can dynamically take a bunch of these labeled sliders, format them into a group box, and create something we might call an attribute view. So now we've got this attribute view, which is a brand new component. And the key here is that creating one of these attribute views, or many of them, is just the same as creating that first label that we created, or that slider. So now we've moved kind of through this blurry line between kind of what you might think of as widgets, and we're starting to see something that looks more like an application view using the same component model. So just to kind of round this out, we could take that attribute view that we created, combine it with a couple of other components that we created, and then now we have a contact detail view. And the key thing here is the contact detail view is now a component. It's a class that we can instantiate and render out as many times as we need. So just like we did that with the slider, anytime we need a contact detail view, we can just create a new instance of that and render it out. And because all of the DOM required for all of those child components are encapsulated in that contact detail view, it becomes a really simple way to build higher levels of application functionality. So again, I want to kind of break this down real quick so you can see what kind of the elegance and the beauty of what's going on here. So at this contact detail view, we may be composing this out of 4 different components. Say the toolbar at the top, the image on the left, that chunk of stuff over there, we called it a person detail view, and the attribute view. So in the definition of our contact detail view, it may contain this representation of the components. So as we kind of drill into these, so we can now take a look at how the attribute view was constructed. And that was constructed out of a group box and some group box headers and labeled sliders. And then we can drill into the labeled slider and see that that was created out of labels and integer sliders. And it's only when we get all the way down to the slider kind that we're actually seeing the HTML. And so what this does is it allows us to very quickly create reusable components out of HTML, but then start working at higher levels of abstraction. And if you ever build an iOS app or an Android app or any other app on any other platform, you're never working at that core graphics layer, right? Which is really what HTML is when you're trying to create these native UI applications. Instead, you're working at higher levels of abstraction, things like menus and sliders and pickers and buttons and all of the things that you need to create an application. And we think that's really cool. So we've got a few more minutes here. I'm going to my last example here is to show some of the complexity that we hide inside of components that we provide in our Enyo framework. That hopefully shows up the kind of elegance and the elegance of being able to use a component model to create these native UIs. So the example is kind of infinite scrolling list. So this is a UI metaphor that you really can't get away from if you're trying to create a native quality application. But getting to really smooth scrolling, kind of that buttery iOS scrolling that users expect on the web stack, especially when your lists are really long. So think a email inbox that might have 10,000 items in it, or a LinkedIn newsfeed that just goes on forever. So doing that on the web is actually really tricky. And it's tricky because if you have 10,000 email items and you just throw all that into the DOM, which is what most templating libraries will do, right? If you have a collection with 10,000 items, you're probably just going to kill like mobile Safari. It'll just die. Just because it's not good at handling that many items rendered into the DOM. And so to work around this, we do what most other kind of competitive platforms, things like iOS and Android do, which is we flyweight our list. So flyweight is a pattern where you, to minimize resources, we're only going to render a subset of the items into the DOM, and then we're going to dynamically, as the user is scrolling in real time, swap in new components and take old components out. So that keeps our memory footprint low, and it allows the scrolling smoothness to be there. And just to give you an idea of the kind of complexity here, so we would create two divs into the DOM like this, and then in our the list implementation, we'll take the list components that we pass it, and I'll show you this in a second, and render those into the first page, and then render them into the second page. So this will happen on the initial render. And then as soon as the user starts scrolling the list, right? So we start scrolling the list, and the first page starts to become off screen, then the list will automatically, in real time, kind of transparent to the user. They're just flicking the list. We'll take components out of the DOM, re-render new components into the bottom of the DOM, and then keep moving that list up, right? And this kind of just repeats. And the real beauty here is that for the user, because we've encapsulated all this really difficult functionality inside of a list component, for the user to use a list, it's just as simple as adding a one-line list item to their app, and then providing that list the components that will form each of the rows. And the real key here is that because we're using a component model, we can hand the list any component that we want, even that contact detail view that we just created. So that's a custom view that we just created. We can hand that to the list and ask the list to render that. And because all components have a common API for rendering themselves, creating themselves, rendering, destroying, the list can manage the lifecycle of those components itself without the user having to even think about what's currently in the DOM at any time. So we think that's really cool, and when you play with the Enyo list, hopefully you'll see that it actually feels very similar to native functionality, and that's a really hard thing to do on the web. So I want to kind of end here with a quick little discussion of why we're working so hard to provide native quality on the web, right? So you may be thinking like, why don't we just let web pages be web pages and native apps be native apps, and the world will get along? And the answer is that, especially at WebOS, we fundamentally believe that users shouldn't have to and don't want to care about what devices or what platforms they're accessing their data and their content from. They have apps, they have data, they have content, and they want to get to it wherever they're at, whether that's on a phone or a TV or a tablet or maybe a car someday. And there's really no other platform other than the web that has the reach and the power to get to all of those platforms. And that's because everybody has a horse in the web race. And so no one's going to no platform providers are going to get left behind in the web. That said, users shouldn't have to expect one user interface for accessing their content through the web and another one through native applications. And so that's really what's driving us, to help push the web to become that universal application platform that can provide kind of the bridge to users, to all of their data, all of their content everywhere. So hopefully that sounded good. We're running a workshop tomorrow, so if you want to see how quickly it is to get up and running with component model and building applications, we'd love to see you tomorrow. So that's it.